Good. It's 3 o'clock European Central Time. Good morning, good afternoon, good evening to everyone around the world. Welcome to our February 2025 coffee talk. My name is Hannes Reuter, and I'm still this summer the president of the International Society of Geomorphology, and with that, then I welcome you all to this event here. As usual, for all the newcomers, just 2 minutes on what is geomorphology, and then I will quickly introduce you to our speaker here, which will present today. Did he just disappear? No, there, Giuseppe, you're still there. And then we go on. With that one, just for everyone's notice, we would like to record that meeting, this meeting here, and put that on our YouTube channel. And with that one, we hope you all approve that we're recording that one. And if you're not, then you can leave now. And with that one, I would like to ask Carlos to start the recording. And then please tell me if the recording has been started, and then we can go ahead.
Yeah, we are recording.
Okay, thank you, Carlos. Yes, welcome everybody to our February 5th Geomorphology Coffee Talk. Geomorphology is about the science of quantitative land surface analysis, and we are a non-commercial, non-governmental association of researchers and experts which try to do things, exchange about digital elevation models, how we can process it, and what can we analyze it, and we want to improve our understanding of the Earth based on digital elevation model. Our website is geomorphology.org, and we have also a biannual conference where we meet, and you will see in my next slide about where we meet this year. And we're also trying to organize sessions at the EGU, at the AGU, wherever we can do locally, so the community can come together there. Besides that one, as we are all living in 2025, we have some virtual representatives, like our coffee talks, like what we do here today. We have our website. You can reach us out on Twitter, on Instagram, on YouTube, and LinkedIn. And you find our data at the Zenodo community. So what you will have today here in the next 60 minutes, we will have 5 to 20 minutes presentation by Giuseppe. And then afterwards, we will have an open exchange. And today, from this morning, I have seen that we had 46 to 50 registration for that meeting today. And we will see how many we are at the end today. I see we are 30 people now in the meeting. So, and with that one, I invite you all to come to our Geomorphology conference, 9th to 13th of June this year to Perugia. The easy chair was there to submit your abstracts. So now the review process is ongoing, and the reviewers are bidding to review the processes. And we all hope to see you there. If you have not submitted your abstract, then it's now a little bit maybe late. Maybe discuss with Massimo and Peter, who are running the show behind the scenes, what could be done. Flyers to promote that event are available from Massimo, and you can also share it on your social media accounts. And with that one, I stop my screen share here for today, and I want to introduce here Giuseppe. To you, he's a forester. Many of you from the community already know him since years, and we are looking forward really to an interesting presentation from him today, where he will talk about the height. No, sorry. Now I forgot the correct name. Apology. Geomorphology, Hydrography 90 meters, sorry, pushing the boundaries of computational hydrology. Sorry, that's the correct title. Giuseppe, and with that one, I think I don't want to waste more of our times here for today. Go ahead, share your screen, and we're looking forward to an interesting presentation here.
Thank you very much, Hannes, for the nice introduction. As you mentioned, everybody knows me, but if we don't, we will have the opportunity to meet each other probably in Perugia in a couple of months. Oops, I went too fast. Okay, I think you can see everything.
Yes, I confirm with your slides and we hear you loud and clearly.
A few years ago, I'm embarking in this huge computation for the analysis and the stream network at global level using 90-meter digital elevation model. The title already says something about the complexity of the methodology and why I choose this title, Pushing the Boundary, because they're really struggling and pushing the computation to the maximum level by combining several techniques of high performance computing and parallel computing and open source software. So I'm going to talk about the Hydrography90m that has been published a few years ago. Here below you can see the title of the paper behind and the author list. So on the talk, I will review the technical background very fast. Most of you will already know. The methodology in the data processing, a kind of description of the workflow that I did, the validation procedure that we implemented, and the computational process that is behind the massive data analysis. And then I will come with some conclusion and the knowledge transfer that is proceeding my activity. So the theoretical background, using of the dam, I will cover it fast. The flow direction and flow accumulation algorithm that are in place, and the delineation of the stream network and basin delineation. Okay, let's go with the digital elevation model. So Dai Yamazaki, a few years ago in 2017, released the Merit Dam, and later on released in 2019 the Merit Hydro. That is an error, kind of almost error-free. There are always some errors, but the best that we had at that time in 90-meter resolution, and has been always also hydrologically corrected. So I selected that digital elevation model as a source of data set for doing all the processing. So everything has been aligned. They use it on the base of the Merit Hydro. Besides, I also maintain a strict, rigorous procedure to have everything aligned. Also with the previous data set that has been derived with the Merit Dam that is called geomorphology90m. So in other words, if you use the geomorphology90m that depict the geomorphology and the hydro90m is going to be all of them under the same, let's say, raster standardization procedure. So everything is matching very well from a GIS perspective. So based on the Merit Hydro, let's cover it a bit, the flow accumulation. So you can see that based on the digital elevation model, you can depict where the water can go, and you can count the flow accumulation, that is the area upstream to each single cell and where is going the water. From the flow accumulation, you can derive the stream network, and in the end, you can have the full depict of the stream network at global level. So coming back in the flow accumulation, there are different algorithms that can be used for the flow accumulation to define the flow, to identify the flow accumulation, to calculate the flow accumulation. So you can have a single flow when one cell is bring the water to the next cell, and you can have different level, or you can have multi-flow where one cell is distributed to many cells. Okay, and in this context, there are different algorithms, and one that has been implemented inside GRASS is the multi-flow R8 R8. Okay, there are also R infinity, but that one is not implemented inside grass. So I use this one due to the complexity and the better result compared to the single flow. Some background, please. Can you stop? Okay, thanks. Methodology and data processing. So we will see a bit of the terminology that I use it in the paper. The tiling system that I use it in order to process all the digital elevation model, and the computational workflow to have the global flow accumulation, and then all the product as a global basin, sub-catchment, and all the stream product that has been derived from it. So let's go a bit on the terminology that is very important. So one of the most important part in the stream network delineation is the definition of the upstream contribution area. So that one is where the stream start. Be careful that when we identify, in my case, in the Hydrography90m, when we collect, we say stream, doesn't mean that there is water, okay? So it's just the starting of the channel where potentially can be water. And then I will explain what is ongoing for the next step. So this one has been setting very small, 0.05 kilometers, so half hectare. So compared to the previous data set that has been always to more than 1 kilometer, 1 kilometer, 5 kilometer, and so on. These allow us to really see the headwater that has been never depicted in the previous data set. Then we have all the order that probably you already know: basin drainage divided, identify the basin. We have the sub-catchment and the sub-catchment drainage divide, each single one, the segment, the stream segment, and so on. And in the end, you have the outlet when it's arriving to the sea. From the computational perspective view, when we talk about digital elevation model, spatial modeling in general, we can work in a square cell or square tiling system, okay? Because the relation between the different, between one cell and the others is not so complex and so large in space. So we can working in a regular tile system. And what I mean for regular tile system, so we are working land cover, we can tiling, and we can have maybe a bit of overlapping 2-3 cell to allow the missing of border effect. But when we work in the catchment, everything need to be, have all the stream network, all this, the basin need to be inside to inside to our tiles. And in that case, we need to work in a regular tile system where each single cell, each single tiles include the entire basins. Okay, so everything that has been cutting out need to be computed in the next by tiling system. And we will see a figure right on now that is explaining this concept in the global view. So over here you can see, let's go to South America. We can see that, for example, all the Amazon River Basin has been included in these tiles, and so on. For the below has been included in this one, and so on. Everything that has been computed in the broken part, broken by the tiles, cut it up by the tiles, will be removed and computed in next one. So as you can see, there is a lot of overlapping procedure and computational issues to be solved during the alignment of all the different tiles. Why we have this problem? Because a few years ago, we will not be able to use the full matrix at global level to have a computational flow, a computational analysis for the 90-meter resolution. Was possible in a 1 kilometer with only one single shot in grass, but was not possible for RAM limitation and data type RAM limitation for the 90-meter resolution. So I implemented this procedure that was quite quite particular for handling the different part. And of course, later on, there was even a procedure to align everything on the final result. So the final result has been tiling in a normal system, in a normal tile system. And this is the tiling system that you can find in the downloading page, where each single tiles you can downloading and for the different products that are available. So over here you can see the different color for the basin, and of course there are also the big one you can spot very well, and also the micro one for the more particular place. So let's see to the flow of the computational procedure. We have the first definition is for each single tiles has been identified the flow accumulation, the stream segment, and the stream basin, thanks to our watershed, that is the main command in grass, our stream extract, and our stream basin, to identify the three of them. Then we select only the entire basin, so only the basin that has been computed entirely, not the one that has been broken. And then we aggregate everything. We use this entire basin to mask out the flow accumulation, the one that are belong to the not entire, and we compute the global flow accumulation. At this point, we have a global flow accumulation that can be used to reiterate once again all the flow direction, flow accumulation, and having in that place one unique raster that can be used under the same irregular tile system to produce all the different global flow direction, global unique basin, global unit segment, and global unique segment. Of course, this is a complex procedure that has been, let's say, simplified with this flowchart, but is a series of scripting procedure in grass running under bush environment, and all of them are in cascade mode, so the full system can replicate in 4 or 5 days inside to the HPC of the Yale University. This is very important because the different procedure need to be run several times in order to be checked that all the different tiles has been aligned in the full matrix. With this one, we need to be very picky on the tiling system and the cell size, and they need to be very precise, because a very small rounding of the cell size, even after less than 90 meters, several digits after the 0.08333 and so on, can be result in a mismatching, especially when you go down into the Australia area, because the one single missing digit of the pixel can result in a shift in the tiling system. So it has been really tedious in this kind of aspect to see. In the end, you have the final product that you can see the different sub-catchment. You can see the different basin, and inside to each single basin you can have all the sub-catchment, okay, identifying, and of course the stream network and the flow, and the stream network and the flow accommodation. Okay. At this point that I had the full product, before to compute all the stream property, I need to validate this kind of product. So we can have the validation of two main products, the flow accumulation and the stream network delineation. Okay, so if these two we succeed a good result, then we can proceed with the calculation of the rest of the stream product. So for the validation, I use the most available stream network, that is the NHD plus high resolution, that is 10 meter resolution, based on 10 meter resolution, and is a mix of the digital elevation model, stream network definition, and also visual interpretation coming from a really photo interpretation from the United States. So I use all the data set available, so big massive quantity, and I cross over the flow accumulation of the NHD plus that is provided inside of the data compared to the Hydrography90m. You can see a very nice high correlation between the two data sets. Of course, there is also some errors, but the density, you can see the high density of the flow accumulation pixel is really combining, explain very well the result. We can also have a validation from the visual inspection, and in this particular case, you can see the validation between the Hydrography90m and the NHD plus, so the pink and the blue. The pink and the blue, you can see that are matching very well. Okay, so there are some cases due to the digital elevation model difference, resolution different, that are depicted, but you can see that compared to the other product, to the Merit Hydro and to the Hydrographic and the Growl, are completely overstanding the situation. So you can see also in this case where the Merit Hydro is very short compared to the Hydrography90m HD plus. So the visual inspection already telling us that we are able to depict the headwater of the river. There are some cases that, of course, there are some mismatching. Like in this case, the Hydrography90m is still going up in the upper valley, but these one are the part that later on, based on the presence of water, can be pruned back. So in this case, we overestimate the length of the stream because we are mapping the channel. We are not mapping the presence of water. So the visual inspection is also supported by the validation procedure that has been done by, still with an HD plus, by so say if this one is the modeled hydrography. Okay, so you can see that the different, and this one is the distance, one cell, two cell, and so on. So you can see that 25% of the cell belong to the same cell in an HD plus for the Hydrography90m. So one cell, one shift cell, you can have the second one, and then the rest is just off of three cell. Anyway, with the 50% of the probability, 50% of the cell are really matching in one or two shift, one or two cell shift. Rather, the other one, the Merit Hydro rivers, as you can see, they're much lower in terms of overlapping cell. And in this case, you can is depicting also from the previous image where you can see that there are the mismatching is also present from the visual inspection. At this point, we can use the Hydrography90m stream network to derive additional product. And let's see what are the additional products that are present in the full data set. So we have 2 terabytes of data set. So we have the base one, as I mentioned, there are the base one, and then there are the topography and topological property of the stream network. So we have a flow accumulation, flow direction, drainage basin, outlet, depression, stream segment, and sub-catchment. These one are really the core of the files of the product. Rather than we have been derived stream slope. So we have 4 raster, different stream order, the different typology of this stream order with one vector that identify all the different stream and upper stream contribution segment. 11 layer of stream distance that are very useful. So these one are just an example of one of these, and these are really important for the different method, for the different machine learning implementation that can be done with this kind of product, and the different modeling procedure that can be done. Then we can have also other stream segment and 3 kind of flow index, like like the topographic flow index, for example. So all these layers can be extracted, can be downloaded, of course, from the hydrography, hydrography.org. We implemented, we get this domain, was free, was available and was free. So, and over here you can see a nice video that is representing the product, and also you can have all the different links for downloading the Hydrography90m product that has been hosted in the IGP server in the German Institute over there. Over there, they have also implemented the other outdoors. They also implemented a WebGIS interface where you can link, zoom in, zoom out, and do some query in the data set and then downloading what you need. And of course, we have implementing also a batch downloading procedure where you can go there and you can have the scripting procedure to download the different files. Something that has been also implemented by the German colleagues are these really wonderful hydrographer that is a R package that interact with the data. So they are able to download the data and getting, for example, stream property, stream segment in the interactive way. So it's very well documented with a GitHub repository and also with a paper that has been released 1 year ago. So is really getting a lot of importance. You can install it directly as with the install GitHub over here, and you can use full. And we are getting really an increase of user using this product, the hydrography product, thanks to this R package. Also because working with this 90-meter resolution with so many data is quite complex, so is really driven to the direction of computation. And in my case, I'm also using this data set for a future implementation in machine for the discharge model. So as I mentioned, the scripting routine, there were 52 bash script, more than 4,000 line, all of them built in a cascade mode. In this way, I can replicate every time that I see eventually mistakes and bugs and so on in the code. I can replicate the full process in a single shot in 4 or 5 days. And really has been running so many times in order to be able to depict all the different errors that were especially due to the overlapping tiling system. You can consider that from a computational perspective, one single tile needs 70 gig RAM. So, and this one was available inside to the high performance computing. And we use it 99 irregular tiles. So you can see that the red tiles, there were 99, and the work has been done with more than 12,000 core hours for one single run. So every time that I was running the full system for depicting errors, there was more 12,000 more hours. Okay. The software that I use the GDAL for all the tiling and cropping and mosaicing and merging of the tiling system. PK tools for the different masking creation in the for the tiling, masking of the tiles and so on, and classification of the unique ID numbers, and then geographic graphs for the real hydrology and stream segment property with the different R watershed, R stream extract, R stream basin, and so on. Let's see a bit about the delimitation. So the system does not allow channel bifurcation yet. There is a working process, and in particular, I need to test it. The team from GRASS told me that there's been achieved this issue in bifurcation, but I didn't have time to test it, but it's going to be in my to-do list. I depict the small headwater were located 90-meter resolution. And as I mentioned, the stream network doesn't mean that there is water. So now we are We are in the second process where I'm building up an hydrological model to depict the amount of flow, so water discharge, and then whatever there is no water, so zero water, they will be pruned the stream network. Actually, there is always an ongoing process to have stream network length that is changing according to the season. So in dry season is going to be shortened, and in long raining season is going to be longer, the stream network. So it's going to be 12 months, let's say 12 months product for the stream network. Extremely flat area, as you know, is always an issue in this flow routing system. For example, I was always testing in the Pianura Padana in north of Italy, where there is a lot of super flat, and also there is a lot of anthropic channel that sometimes they goes against the main flow of the water. So that one can of course can have some issues in the computation. The tiling system was implemented to not overpassing the 2 billion billion of cells in the matrix, because it was linked to the data type of the int32 variable, but now has been now also the team grass has told me that has been passed to int64, so we can achieve it a bigger matrix. Okay, so this will open the resolution to open the high resolution and open the possibility to have only one shot full computation for the full globe. The problem I just mentioned, there is a kind of thinking about to use the same kind of methodology for the Copernicus dam, 30 meter, but also there is a lot of issues with it, because not always the high resolution bringing a better stream network, because the stream network can even go inside to the motorway, and we can have a stream right in the motorway because it's so flat, so straight, and so that we can address in these issues. That I mean, there are going to be issues in this kind of step. Yeah, and the last one, modeling global discharge, the one that previous mentioned. So this Hydrography90m is using by our group for different kind of application in fresh flow and sediment transportation, population and nutrient concentration, biodiversity, especially from the German colleagues, public health, vector-borne disease in my group, geopolitical and resources challenging, and as you know, issues in war and so on due to the water security, water resource management, food production, and so on, and is part of a United Sustainable Development Goals. So the water system, so is really a unique data set that can be used in different contexts. Beside the research, I'm very keen, as you probably know, in running courses in geocomputation, machine learning. We are more than 50 years of experience running, mainly in United States and Europe, but from time to time we also go to developing country where this product, being an open source product, are really appealing compared to the proprietary software that can be used without any constraint. So the next one is going to be in autumn 2025. You can reach me directly in spatialecology.net if you want to join the course in geocomputation and machine learning, and you can be registered in our mailing list that is sending advice every 2-3 times a year. So that's it. So now let's open the floor to different questions and so on, and I will be here. You are not in mute, but I cannot hear you.
No.
Okay, now yes.
Thanks to that for your really interesting presentation. Really interesting for me. I have many questions, but I don't want to monopolize the whole situation. So floor is open for everyone. Hands up, please unmute yourself, and I will. Jung Feng, please go ahead. You were the first one, and then Martin.
Right.
Yeah, now we can hear you.
No, not really.
No, I can hear him. Oh, one more time. You can? No. You had unmuted yourself before.
No.
No. No. Then let's. Ooh.
No.
No. Okay, please put your question in the chat and I will read it out loudly. Martin, over to you.
Hi there, thanks. Thanks for the very nice presentation. I have many questions also about scaling with Copernicus dam into 30 meters. But I think the main one would be, how does this relate to the Hydrosheds project, which is also working on a version 2? Well, they have been working on a version 2 for a long time using 10 12-meter resolution data. I wondered whether you could comment about that.
My work, I don't know. I'm not working with them. So how it's related, I don't know. I can't reply to this. So can you formulate better the question? Sorry.
Well, maybe that's answer enough. I mean, I also don't work with them, but I see it as a similar initiative that seems promising. But
Yeah, so I don't know at which point they are. I didn't start at all, frankly speaking. So it's just something in my to-do list. Now I concentrated my attention on the discharge modeling to have the pruning of the stream network. But my feeling is that with the 30 meter, we are not going to gain so much. Probably we are going to gain in the flat area, but for the rest, and maybe in the headwater part, in very complex terrain mountaineering, but there are going to be more errors due to the high resolution of these, like one that I mentioned, that the stream network goes inside to the motorway because it's very flat. And so
right. But I
let's
would expect, given Merit Hydro, and appreciate that initiative, we're also using that data set, or have been using that data set a lot at our institute. But of course, it doesn't correct for urban areas, so it doesn't remove buildings from the data set. So that's a rather large problem, right?
Yeah, urban data set they didn't remove, yes. Forestry, yes, is quite well removed. And I didn't test yet the Copernicus global data set, and even the FabDem, for example, I didn't use it. So I don't know the combination of or which are the result from this.
Okay, let's get to the other questions. Thanks.
Okay. Lawrence, over to you.
Thank you. Very nice presentation, Giuseppe. I'm just wondering your thoughts on aligning your work with SWOT data, because that's currently snapped to the SWORD network, which is based on merit as well. So I kind of wonder if you could sort of relate Hydrography90 to the SWOT data.
To the SWOT,
Yeah.
I'm thinking to use it in my hydrological modeling. But I didn't use it because I'm mapping what is in the past in the last 40 years up to the
Okay.
and this what it was coming out like 1 year ago or something.
Yeah.
So I didn't, but for sure it's going to be a good data set for the water quantification. Yes, water
Yeah,
discharge.
absolutely. If you're doing anything in the near past, it's brilliant, and try to align with it. Brilliant. Thank you.
Okay, next one, John.
Hi, Giuseppe. Really enjoyed the talk. Thanks so much. Like everyone else, I have so many questions to ask, but I will keep it to one. I noticed in the talk you were describing the different algorithms, flow algorithms that were available. It looked to me like you had settled on a multi-directional version of row 8. Is that correct?
Yes, yes. The one
Is it
implemented, there is a multi-flow and single flow.
Yep.
So the multi-flow is only one, and is dividing the water flow to the 8 cell. And there is a percentage of how many percent goes to each single cell downstream. But it's not implemented the infinity, for example, in graphs.
So, I mean, one of the characteristics of row 8 is that it's stochastic. Is the version? Sorry, I'm a little ignorant when it comes to graphs, but is the implementation stochastic? Does it change every time you run it?
No,
The
no,
accumulation rate?
no. Is a
Okay.
percentage, yeah, also Massimiliano confirm, is a percentage that is fixed. You can change the percentage for each single cell, but they use the default after a few testing. And so it's not stochastic, it doesn't change. Yeah.
Perfect. Okay. Good. I'll have to look into that then. Very interesting.
Yeah.
Thanks.
Okay.
Great talk.
Okay, Giuseppe, some recommendation from the group. Maybe you stop sharing your screen if you don't want to do, and then we can all see you better.
Right.
So then next question is over to Massi. I have him on the list, and yeah, thank you for the colleagues who have lowered their hand after they have spoken. Thank you.
Yes, hi again. Ciao, Giuseppe. I have a simple question. I don't remember. I may have asked this question before, but either I don't remember if I actually asked it or I forgot the answer. So, do you provide these irregular tiles you use in your download area?
Yeah.
Maybe not. You do. Okay.
Yeah. There is a shapefile.
Okay.
I will confirm. I will go back and check it, but I should be the shapefile. And there is also another important file that is called a computational unit. So the regional unit. Regional unit are nothing else that a group of basin that are the entire basin.
Okay.
Okay. So with that one, can use it for the multi-core computation.
Do you expect these tiles to be valid with the 30 meters as well?
I would say yes, because these one are included.
Because it's just a tiling system. Then you actually run the watershed algorithm.
Yes, also because they are in very huge. They have also very huge overlapping.
Yeah.
So
Yeah,
even if there is a kind of shifting in the border effect of the basin, is not going to be so big, because the overlapping is 1 or 2 degrees sometimes. Let's say 1 degree. So it's 100 kilometers. We are not having basin delineation shift of one degree, 100 kilometers. Yeah.
Okay, thank you.
Welcome.
Okay. Further questions? Yufeng, have you put in your question in the chat? Yeah, sorry. So the question, thank you. Now I've seen it. Sorry, there were too many things. Giuseppe, here's a question from Yufeng. Towards the water presence, do you also generate the hydrology in the Sahara Desert? If so, how did you derive the catchment area? Or is it making sense to create hydrological parameters there?
So once again, we are defining the stream network as a channel, okay, where the potential water can be. So in this case, also in the desert, there is the stream network without water, of course, but is there, okay? And also there, we identify the internal sub-catchment. So we have the internal drainage basin, of course. Yeah. Okay,
Yeah.
Feng.
Okay, thanks, Giuseppe, because that's, and I think I see Yufeng also said yes, so it's fine. Cool, because that came, I think this is the point. I remember the work done by the colleagues in the Joint Research Center where they were pruning the water, the stream networks, then based on geology and based on ecological conditions. Because if you are in a sandy environment compared to a hard rock, you will have completely different headwaters, and all that will influence. And that was a question for me. Yeah, if you have done some comparison against Global Water Explorer, maybe, or some
So
of
this
these
is the work that I'm running right now for the river discharge modeling.
Okay.
And based on the discharge modeling, I will prune it. So discharge less than 0, no streams.
Okay.
I will pruning the stream network, but it's still ongoing project. Yeah.
Okay, good. And then one question, because we have now moved on, and I mean, we have now machines which can have, besides the grass being developed now further and doing the 32, I mean, now we can get machines with 1.5 terabyte of RAM and 48 cores. I mean,
in the beginning was not the problem of the RAM in the hardware, but there was the problem in the software. So the software, the upstream network was not allowed 2 billion cell more.
Okay.
So I have availability of RAM in the Yale cluster, but there was not the software handling. Now I talk with the Grass developer. They told me that now should be possible, but I didn't test to increase. I don't know how much we can increase. Probably continental level can be done without all the, so let's say 7, 8 tiles can be done, and that's it. But I didn't test.
Okay. Good. Yeah, that's because we see, sometimes we see this kind of developments in the past. We didn't have enough memory, and then we did all kinds of workarounds to figure out. And now, one of my machines where we were running it for 3 weeks. Now we just bring up a big machine and it's done in 3 hours. So I mean, this is like in terms of computational cost, sometimes this is different. Okay, anyone else wants to have the hand up or wants to have the floor, please? There's one new message, sorry. Yeah, so from Alicia, there's a question. Have you planned to calculate the topographic wetness index?
Yes, it's there. Is it there? Topographic wetness index is there.
Okay. Did you try different ones or just TDI?
There are 3 of them. I don't remember the name. SPI, STI. There are 3 of them.
Okay, good. Thanks. Yeah, okay. We understand your situation, Alicia. Everyone has his own. I had my kid even coming in here as well. Okay, good. Someone else wants to have the floor? If this is not the case, then let me wrap up the meeting for today. We have seen a really nice, interesting presentation by Giuseppe where he informed us about his work on the hydrography 90 meters with all his pitfalls and advances, what he has done in the past, where it was failed and where it was superseding other products. He has shown us really nice, interesting validation results, and he has explained to us how it can be used in various environmental use cases. And with that one, I think everybody, thank you for attending today's coffee talk. And we all hope to see you at the Geomorphology conference in June. And as we have not yet a speaker for the next coffee talk in 2 months from now, if someone would like to have the opportunity to come and speak in 2 months from now, I'm still happy to receive one name. We discussed upcoming now Alex Brenning with Arsaga. I will ask Alex if he wants. I still would like to have more proposals because the agenda looks a little bit empty for later on in the year. We have noted down for October Dr. Sorry for my mispronunciation, Li Yang-xiong. Sorry, I don't know if I pronounce it correctly, but I mean, this is noted down for in October, and we miss some more for December. With that one, thank you very much, everyone, and enjoy the rest of the day, the night, the morning, the day. Bye-bye.